All right, this brings us to our second to last video, which is going to cover the Pythagorean theorem identity. So we've been talking about these triangles that we're creating in the unit circle, or it could be somewhere else, and we've also discussed that, this movement left and right represents your x movement, up and down represents your y, and your hypotenuse is always known as your r, because it's the radius of your circle. Well, if we are going to let r equal 1, all right, we know, well, first, before I even do that, I know for the Pythagorean theorem, it's x squared plus y squared equals r squared, right? Well, if we're in the unit circle, that would just equal 1, right? Because 1 squared is 1. Now, the thing is, though, we remember that in the unit circle, our x's, remember, it's just in the unit circle, not when you're not in the unit circle. Your x's are sine. Oh, no, they're not. I always do that just because they're first. Your x's are your cosine theta, and your y's are your sine theta. So now what I can do by substitution is, well, if my x's, that would be cosine theta squared plus sine theta squared, well, that would equal 1 squared. Well, we can clean this up a little bit. One thing is, and it's just, I really don't have a rhyme or reason for you, but one thing is that we usually write sine first, and if you didn't, it doesn't matter because addition, order doesn't matter with addition. The other thing is, a lot of us get lazy with these parentheses, okay? And if you don't have them, it looks like you're just squaring the theta and not the whole function. So that's why they created a shorthand where they put the 2 between the function and the theta. So I'm going to rewrite it how you'll see it in your book. Sine theta squared, so this is just your shorthand for writing something squared, plus cosine squared equals 1. So this is how you'll see it in your book. Now this is something known as an identity, and what that means is it is true for whatever value you put into theta. So if I put 30 in there, it works. If I put 45 in there, it works. If I put 70 degrees, it works. If I put pi over 2, it works. It works for everything out there. That's the definition of an identity. So this equation is always, always true. It's just that your angles have to be exactly the same. All right, so this is known as identity. You want to get this memorized, if not now, but you got some time, but especially before we get into Unit 6. You're going to be using this identity often. I heard this identity as a pickup line once, and I was watching some, embarrassing reality TV show, and it was, I don't know, I'm probably dating myself, but it was called Beauty and the Geek. And the geek went up to the beauty and said, why don't you be sine squared and I be cosine squared, and together we become 1. I say that joke because it's ridiculous. Also, sometimes it helps us memorize things. This is true no matter what. I can also manipulate this equation, okay? And I could go ahead and, let's just say, because it's an equation, I can do whatever my little heart desires. I could divide everything by sine squared. Well, sine squared divided by sine squared is 1. Cosine squared divided by sine squared, well, we talked about that sine over cosine is tangent. So then that would have to be cotangent squared. And we know the definition of 1 over sine, that is cosecant squared. So we have just found yet another identity. And again, these are going to come into play big time in Unit 6. But I do want you to feel comfortable with them now. Maybe not memorize them, but you do feel comfortable with them. The other thing I could do is I could take that original identity and I could divide everything by cosine squared. Well, sine divided by cosine is tangent squared. Cosine divided by cosine is 1. And 1 divided by cosine squared, that's the definition of secant squared. So we just found another identity. So you should not have these memorized at this moment. You just learned them. But maybe after doing all the homework, it will get better and you'll retain it. So when it does come back and we start using them a lot in Unit 6, it's going to be easier for you. For me personally, I have this one memorized, right? That one's an easy one. And then what I do is I just derive by dividing by sine squared to get this one, and divide by cosine squared to get this one. Okay, so then I don't memorize anything else. I'd rather, actually find it, because then I won't make any silly mistakes. And the reason we're talking about these identities now in this unit is because it's going to be an option to solve for some of the problems. And you get to choose, this is the nice thing, you get to choose which method you want to use at this point, okay? Some of us are more algebra, right? So maybe we want to use more algebra, and some of us are more visual and we'd rather create a triangle. So that is up to you how you want to do it. I'm actually going to jump the gun and do B real quick. It says find the exact value of sine squared of 50 plus cosine squared of 50. And hopefully this sits well with you. That just equals 1, right? Because my thetas are the same. I'm squaring them and I'm adding them, and that's just what the identity says. I'm going to C. I'm actually going to skip it because you know me, I like to do things out of order. That will come back into play later on in some different unit. All right, so now going back up to A. Before I do that, actually, I'm going to throw something else out here. So maybe I say 3 times sine squared of pi over 6 plus cosine squared of pi over 6. Okay, well, this is your identity. That equals 1. So then this thing would equal 3. Okay, so I want you to recognize the thing you're checking for is your angles are the same, the sine and the cosine are squared, and it's addition. If you didn't have all those met, you'd be a little stuck and you'd have to go to your unit circle. And I actually, just to convince you a little more, look at pi over 6. Oops. This is pi over 6, okay? If I were actually going to say I didn't know the identity, I could go to my unit circle and evaluate and say, okay, well, this also equals 3. Sine of pi over 6 is 1/2, and cosine of pi over 6 is root 3 over 2. Well, if I square that 1/2, I get 1/4. And if I square root 3 over 2, I get 3/4. And what do you know? 1/4 plus 3/4 is 1. So it matches. I'd much rather you use the idea of knowing the identity, right? It's way less work. Because again, we want to just be like quick with our arithmetic so it makes our life easier. All right. So going back to A, we have a problem like this. And I'm going to go ahead and cut this in half, and I'm going to say method 1 of solving this, method 2 of solving this. And this is your prerogative, whichever method you want to use. And like I've been saying, on exams, you would just show all your work, so then I could be convinced of how you found the values. So method 1 is going to be using a visual. And it says cosecant of theta equals 3. And then it says cotangent of theta is negative. And the reason I'm giving you that is because it tells you what quadrant you'll end up being in. Well, if cosecant is positive, okay, that's in terms of sine, that means my y's are positive. But if cotangent's negative, remember your definition of cotangent is x over y, that means your x's have to be negative, because it would have to be a negative divided by a positive gives you a negative. So I'm looking at x's are negative, but my y's are positive. And so that means I have to be in quadrant 2. And hopefully that's sitting well with you from like previous examples too. So your cosecant is 3. Well, that 3 is understood to be above a 1. Remember, cosecant is the reciprocal for sine. Sine's definition is opposite over hypotenuse. So this means this would be hypotenuse over opposite. Okay, and look, that would be a positive 1 because I'm in quadrant 2. Now I have to find that missing side, so I'm forced to use Pythagorean theorem. So I get 1 squared plus my unknown squared equals 3 squared. 1 plus x squared equals 9. So I get x squared equals 8. Take the square root, and I hope you're getting better at this. This simplifies to 2 root 2, because it's 4 times 2. You always have to do that, so don't ever leave an answer as a radical 8, okay? You always have to simplify your radicals. And so this is 2 root 2, but because you're in quadrant 2, that should be negative. All right, so now we're going to go ahead and just solve for the 5 remaining trig functions. So I'll just do sine of theta, and this is the method I prefer because I like to look at things. All right, that's opposite over hypotenuse. Great. Okay, cosine of theta. That is adjacent over hypotenuse. Tangent of theta. That's opposite over adjacent. But be careful, you cannot leave radicals in the denominator. So I multiply top and bottom by root 2 over 2. So I get negative root 2 over, well, this times itself is just 2 times the other 2, so I get 4. All right, well, we know cosecant, but I can still list it if I really want to, so that would just be 3, so that matches. Secant is this reciprocal, so that would be 3 over negative 2 root 2. Yikes, can't leave it like that, so I have to clean it up. So I get 3 root 2 over, and it's a negative 4. And then cotangent theta, there is some strategy. I would flip this one, the original, because then I won't have to deal with a radical in the denominator. So I get negative 2 root 2. So if you have any questions about that radical business, reach out to me. I can give you some extra resources. Now, method 2 is using one of these identities. Now, the fact that they gave us cosecant, all right, that means I want to go ahead and use this one because it has cosecant in it. So I'm going to use, let me change colors. I'm going to use 1 plus cotangent squared theta equals cosecant squared theta. That's true no matter what. So I'm going to go ahead and replace cosecant with what we know it to be, which is 3, and that's squared. Well, if I isolate that cotangent, I'll get that 8, right? Because that'd be 9 minus the 1. Take square root. This is really important. Now, when you physically take the square root, it is plus or minus, right? The issue is, or the key, not necessarily an issue, they told us cotangent's negative. So that forces you to make it negative. And then I simplify it. Okay, then at that point I also know, well, then tangent is just the reciprocal of that. So that would be, but can't leave it like that, and we've already done this work, so I'm just going to jump to here, rationalizing the denominator. Okay, So we have two unknowns we found. We can also find sine of theta pretty easily because it's just the reciprocal of cosecant, so that's just 1/3. And now what you can do is go back up here, and now we'll use this identity to solve for it. So I get, and it's getting messy, so forgive me. So now I have sine squared plus cosine squared equals 1. Well, my sine is 1/3. I don't know cosine equals 1. I'm going to erase what's below here. I'm going to get better at my handwriting on this tablet in due time. Well, if I square 1/3, I get 1/9. All right, if I isolate that, realize that 1 is a 9/9 because I have to have a common denominator. Don't shut down with fractions anymore. Try to embrace them. They're never going away. So I end up getting cosine squared equals 9 minus 1 is 8/9. Well, I have to take the square root. And you have to think, wait a minute. I don't know if it's plus or minus. But again, that information that was given to us in the problem will lead us to which one to choose. We know we're in quadrant 2, so my cosines have to be negative. If I simplify that 8, we get 2√2, and then the square root of 9 is 3. And then your very last one is to find secant. Well, that's just the reciprocal of what you just did. But again, can't leave that radical on the bottom. So I end up getting that. Again, your choice which method you like to use. This is just how my brain might like to look at things. And when in doubt in this class, it's like the best thing ever. Create a right triangle. The advantage of using method 2, you're practicing some algebra skills, which is super important because we need them forever as we keep going on in mathematics. And the other thing is it gets you more comfortable with these identities that are going to come back into play in a couple weeks.